You know the feeling. You fill out a form, click Next, and have to type the exact same information all over again. Or you spend 20 minutes explaining a complex problem to a chatbot, only for the session to refresh and forget you ever existed. We surround ourselves with astonishingly capable systems, yet they possess the situational memory of a goldfish. In 2000, a man named Jeffrey Gordon was selling computers at a Gateway country store. He quickly realized the software was entirely blind to the actual conversations he had with customers. So he taught himself Microsoft Access. He built his own database. It was messy, full of sprawling free text notes, and completely inelegant. But it worked. It remembered the customer. It remembered the quote. It remembered what was still undecided. Gordon had built his first continuity machine, proving an interaction shouldn't restart from zero every time a customer walked through the door. We spend an absurd amount of our finite human lives reconstructing states that already existed, simply because the digital context around us constantly evaporates. Gordon refused to call this a memory problem. Memory is just storage. The actual issue is continuity. Can the next actor, whether that's a human, an AI, or you on a Tuesday morning, actually proceed? To solve this, Gordon developed a framework called C4: capture, comprehension, composition, and continuity. He argued that a request isn't finished just because an AI generates a clever answer. It is complete when human intention survives the entire journey to reach an appropriate consequence. Solving the evaporation problem requires engineering an unbroken bridge between what a person actually wants and what finally happens. Gordon eventually applied this philosophy to civic infrastructure with a platform called Common Threat. Instead of navigating a maze of department-specific forms, a resident simply states a clear intent. They might say, "My mother can't safely stay in her apartment after her fall." Behind the scenes, the platform assembles the evidence, coordinates the agencies, requests missing information, and schedules the appointments. The citizen is shielded from the procedural complexity. They aren't forced to repeatedly type their address into incompatible systems just to get help. When architecture is built responsibly, friction belongs to the machine. A human being should never be forced to act as the integration layer between broken databases. Of course, a system capable of bridging intent to completion becomes incredibly dangerous if it reconstructs reality incorrectly. In a housing legal aid network, Gordon's system made a consequential error known as the Morales matter. It confidently matched photographic evidence of a moldy wall to the completely wrong apartment timeline. Gordon shut down the automated filing immediately. Even though the system had a high average accuracy, he recognized that identical statistics can conceal devastating individual costs. A false positive might buy an organization some time. A false negative could leave a family homeless. This failure led to the provenance layer. The system was forced to attach an evidence lineage to every assertion, clearly separating absolute facts from machine assumptions. True continuity demands that systems preserve their own uncertainty. Automating a decision without tracking where the information came from is a recipe for injustice. Gordon's most personal work took these concepts from institutional efficiency and applied them to individual autonomy, using assistive AI agents called nagamals. A young man named Malik struggled to move his wet clothes from the washing machine to the dryer. Initially, the engineers tried to solve this by programming Malik's AI to relentlessly remind him to move his pants. Then they asked a better question. Why did Malik need to adapt at all? They connected the washing machine directly to a dryer unit capable of moving the laundry itself. The obstacle disappeared. Or consider Elena, a young girl who used her AI rabbit Clover to teach the adults around her. Elena trained the rabbit to recognize her specific sensory overload signals and to understand that a long pause didn't mean she wasn't listening. When machines are allowed to carry context, disabled individuals don't have to contort themselves to fit a broken, forgetful environment. The environment learns how to adapt to them. Later in his life, Gordon's slogan, "Work is for robots," appeared on protest signs and union pamphlets. Many assumed he was advocating for a society of total human laziness. But Gordon used the word work very specifically. To him, work was a task you would happily delegate without losing something intrinsically human. He drew a sharp line between effort that is imposed on us, which he called extraction, and effort that we choose, which is expression. We naturally generate effort around things we love: cooking, gardening, caring for our families. Technology's purpose isn't to eliminate effort, it is to shift the burden of proof. Instead of asking why a machine should do a task, we should ask why a human being should have to. When Gordon died, his memorial service looked entirely different than expected. Following a private directive shared with friends, thousands of attendees rejected traditional black clothing and arrived wearing brilliant florals, bright yellows, and neon greens. It reflected his final advice: be your own best friend, protect your finite attention, and whenever the world hands you a miserable little obligation, give it to a machine. He realized you do not arrive at a good life by efficiently bullying yourself toward it. By engineering machines to remember the busy work, we preserve our time for the inherently human, delightfully inefficient things. We save our attention for the things that are valuable precisely because they evaporate.